Video Manuals offers a series of videos of highway mechanics for bike enthusiasts. This video deals with the Shovelhead Harley-Davidson motor. This is a Shovelhead motor with a cone bottom end. You're looking at the cone or gear case side. We'll turn the motor for you to show you the primary side. The pulley on the primary side drives via a toothed belt the clutch assembly and gearbox. The centre nut was pre-loosened while the engine was still in the frame. For shovel motors there are two types of primary drive systems. With our motor we have a belt-driven primary using a pulley. Otherwise it will be a chain drive, in which case the primary drive would be a sprocket. Firstly, we remove the two spark plugs with a plug spanner or a 13/16 ring spanner. Once the plugs are loosened by the spanner, they can be removed by hand. It's a good idea to change the plugs every 3,000 k's, along with the engine oil. Using a Phillips head screwdriver, we'll now undo the two clamps that hold the carby and inlet manifold to the intake ports on the heads. Unscrew one until the clamp nut slips out of the retaining clips on the clamp. Spread the clamp and gently feed the clamp past the carby. Loosen the second clamp until it rotates slightly. The clamp could be removed at this point, but it's easier to remove it once the carburettor has been removed. Taking hold of the carby, we'll pull it down and then pull it away from the rubber that has no clamp. The carby and inlet manifold should come away as one unit. Once the carby and manifold are removed, the two manifold rubbers and the second clamp can also be removed. The rubbers should be replaced before reassembly, as these do perish. If they have perished, they may cause a lot of unseen problems with carburation. The clamp should also be checked for cracks. The next step is to remove our top oil line. We do this by taking two 1/2-inch open-end spanners. Placing one on the coupling, we make this one motionless, while we turn the chrome nut on the coupling. Once loosened using our spanner, the nuts can be removed by hand. When removed, the rubber oil seals are exposed. These seals prevent the oil from escaping and can harden due to the heat of the motor and should therefore be replaced. The oil travels via this line from the rear rocker to the front rocker assembly. And because this is the only substantial oil supply that the front rockers receive, it is imperative the oil line is clean. To ensure there are no obstructions, the oil line should be thoroughly cleaned before reassembly. Once the oil line is free from the couplings, we can remove it. To do so, we push the oil line into the front rocker box and turn the bend up. Then extract the oil line complete with two nuts and two seals. Due to slight manufacturing changes, your motor may not allow you to push the oil line into the front coupling as we have done. To remove the pushrod covers, we'll use a flat blade screwdriver. Insert it like so and give it a twist. These retaining clips keep the pushrod covers closed. After removing all the retaining clips, we then raise the pushrod covers by rotating and lifting at the same time. These covers will be firm and they will collapse into themselves. Do the same for the remaining three pushrod covers. The inside pushrods, by the way, operate the inlet valves. Using clothes pegs, we raise the pushrod covers and clamp the pegs to the pushrods, just below the pushrod covers. This will stop the covers falling while we're working on the pushrods. Using the primary drive, rotate the motor anti-clockwise until the inside pushrod rises and finally falls. It is not a very long movement. The piston in the cylinder should now be close to the top of the compression stroke. Both inlet and exhaust valves should now be closed. With 3 7/16 open-end spanners, we can now undo the pushrod locking nuts. These are the nuts that have the split in them. Holding the two bottom spanners still, we loosen the pushrod. Once loosened, the locking nut can be wound by hand. The locking nut needs to be wound all the way down the pushrod adjuster thread until it rests against the pushrod adjuster head. We then loosen the pushrod adjuster. and wind both the adjuster and locking nut up by hand. You'll notice the top of the split locking nut is domed. The base of the push rod is recessed to accept this dome. As the nut is tightened, the dome contracts, closing the split in the lock nut, thus applying more pressure to the threads in contact with the nut. This creates a much firmer grip, hence a safer locking system for the push rods when the engine is in motion. This is our push rod assembly. The push rod just slides out of the push rod cover. The cover is in fact telescopic. By pulling the top section out and pushing down on the cap, we reveal that underneath the cap there's a washer, a spring and an O-ring. When the retaining clip is in place, the spring pressure on this O-ring creates a seal that prevents the oil escaping from this section of the pushrod covers. The pushrod covers should separate into two pieces. At the top of the pushrod cover we have another O-ring. These O-rings should be replaced. The remaining three pushrod assemblies can be removed in the same manner, remembering to rotate the engine until the rear inside pushrod rises and falls. If we're unable to remove the pushrod assemblies, don't worry. They can come out when the head bolts are loosened. Remember, it's the pushrod on the right we watch rise and fall. We loosen the top of the side oil line underneath the rear rocker box in the same way we loosened the top oil line. Once loosened with spanners, we can wind the nut off by hand. The oil line itself may move around at this stage, but don't worry. Simply let the nut slide down the oil line, and once the nut is free, pull the oil seal out. To remove the head and rocker assembly, we must first remove the 5 head bolts on each of the cylinder heads. We do this by using a 9/16 ring spanner. One head bolt will remain in the barrel after it has been undone. This is quite normal. Using a soft hammer, and while keeping the other hand on top of the rocker box, we tap the rocker box up to break the carbon seal. By giving the head assembly a slight twist, it can now be lifted off. If previously you've had trouble removing the top oil line and pushrod assembly, they can now be removed. Here the valves can be clearly seen, one inlet and one exhaust. We now remove the head gasket. The rear cylinder head assembly is removed exactly the same way. We're now ready to remove the rocker oil feed line. We use 2 half-inch spanners to remove the line. Hold the coupling still and unscrew the oil line nut. The oil line is disassembled the same way as our first line. You'll notice there are 2 nuts and 2 rubber seals. Using a 9/16 ring spanner, we'll now remove the 4 barrel base nuts and triangular washers. It's most important at this stage that you mark the barrels front and rear before removal. Raising the barrel, we can now remove the remaining head bolt. Keep raising and wriggling the barrel until it is free of the piston. Always keep the piston at the bottom of the barrel. This prevents damaging the piston on the barrel base studs. Winding the primary pulley, we raise the piston. We can now remove our piston, its rings and gudgeon pin. The top 2 rings are the compression rings. The others are the oil rings. To remove the rings, we must first prise the rings apart. Getting one edge over the top, we rotate it until it's off. All the rings are removed the same way. In fact, this is the quick way of removing the rings. If you want to use them again, you take them off one landing at a time. Notice there are 2 compression rings, 2 thin oil scrapers and 1 segmented ring. To remove the gudgeon pin circlips, we need a strong probe. There are 2 circlips. We remove both of them. When removing the rings and gudgeon pin circlips, safety glasses must be worn. Generally, the gudgeon pin is difficult to remove. If so, we apply gentle heat to the piston. Don't bash it out, you may cause damage to conrods and bearings. Push the gudgeon pin through far enough to remove the piston from the conrod. The rear barrel rings, gudgeon pin and piston are removed the same way. We've placed a clean rag over the crankcase to prevent the circlips falling into the crankcase. To remove the tappet block, we must first undo these 4 bolts holding down the block. Once all bolts are removed, we place a thumb and forefinger over the hydraulic units. Pulling them together, we can now lift the whole unit out complete. Each unit comprises 2 cam followers. Let's pull one out to see how it works. You'll notice that on one end we have a wheel. This wheel rides over the cam lobe. There is also a hydraulic unit which fills with oil and takes up the free play on the push rods. The oil is fed through here while the push rod rides on this end. The whole unit travels up and down inside the tappet guide block. The same is true of the rear tappet block. We're going to remove the points assembly's outer inspection cover. On this motor we have 2 Allen head bolts. Some motors have in fact 2 rivets, which will need to be drilled out very carefully. Undoing the 2 bolts, we'll take off the first plate. Carefully, using a probe, we'll lift up and remove the gasket. Then we'll undo the 2 Phillips head screws on the inner plate. Remove them and the plate. To remove the points and condenser backing plate, undo the 2 locking screws at the left and right of the screen with a flat blade screwdriver. The plate can now be removed. Electronic ignitions can be removed in exactly the same way. After loosening the points cam retaining bolt, screw it out. This bolt holds the advanced retard unit and points cam in place. Next, the points cam. This cam opens and closes the points. It has 2 lobes, one large and one small. Now for the counterweights or advanced retard unit. Don't be surprised if the points cam and counterweights come out as a single unit. Of course, electronic ignitions don't have this assembly. After removing the 7 bolts holding the cone using an Allen key wrench, the cone can now be removed. We'll hold the cone with one hand and push from the inside while pulling from the outside. It may be stuck, so give it a wriggle. At this stage, be careful the cam itself doesn't fall from behind the cone. Make sure the cam is held back. The large gear is the cam. The gear immediately below it is the crank pinion gear, which drives the cam. The gear to the left is the engine breather gear. From the breather, we take the spacer. Be careful not to lose it. Now remove the gear case gasket. This gasket, of course, will need to be replaced. We now remove the cam. It comes out easily. It's a good idea at this stage to check the cam lobes for pitting. If pitting has occurred, replace the cam. Sitting behind the cam, there is usually a thrust washer and a shim. The shims are used as spacers for adjusting the cam end play. Don't lose them. Let's now remove the breather, which can be either made of plastic or steel. To pull the oil pump apart, we'll need to remove 3 of the 7/16 bolts holding the outer cover to the body, leaving the remaining bolt to hold the case in position. Once the case is removed, the remaining bolt and gasket may also be removed. Next, we loosen the top 2 bolts on the main oil pump body using a 7/16 ring spanner. We then take the circlip off the end of the drive shaft using a probe. This circlip should be discarded. The drive gear then comes off the drive shaft. It can be levered from behind. This gear has a keyway. It's the keyway that interlocks with the woodroof key that enables the gear to rotate. We then remove the woodroof key itself. We should in fact check all keys and keyways for signs of wear and replace them if necessary. The idler gear is the next part to be removed. It simply slides off. The pump body is now ready to be removed. We must first remove the two remaining bolts. Placing the thumb over the shaft for leverage, we can pull the pump body off the shaft. We can now see the other drive gear. The pump body still retains the other idler gear, which should also be removed. The remaining drive gear can now be removed. It's removed by sliding it off the shaft. It too has a keyway. We can now remove the gasket. Using pliers, we take out the woodroof key. Working from inside the gear case, we push the main shaft of the oil pump through to expose a circlip at the end. This circlip, that will remove using circlip pliers, assists in holding the woodroof key in its keyway and holds the gear on the end of the shaft. It's a fiddly job, but once removed, it's usually stretched and lost its tension. The circlip should therefore be discarded. With the circlip removed, the main shaft can be pushed back through the gear and removed from the gear case. It simply slides out. The remaining woodroof key could either be in the pump drive gear or have fallen to the bottom of the gear case. Either way, it can be retrieved along with the pump drive gear. To dismantle the pump body, we use an Allen key wrench to loosen the relief valve and the check valve. The relief valve plug can be removed by hand. It'll reveal the spring inside. The relief valve plug has an O-ring on it, which of course should be replaced. Pull out the spring and the plunger. More often than not, the plunger will not be attached to the spring, and some effort may be required to retrieve it. Next, we remove the check valve plug. It too has an O-ring. Remove the spring and roll out the ball valve. The ball valve prevents the oil running back into the engine from the oil tank. This ball valve should also be replaced. Using a probe, we now push out the remaining seal. This seal will also need to be replaced. Depending on the type of valve plugs used, we may need to remove the valve plugs with a screwdriver. This also applies to this tappet screen plug that also has an O-ring that needs to be replaced. Once this tappet screen plug or cap is removed, we can fish out the spring and oil screen with a probe. The screen actually sits beneath the spring. To remove the rotor and stator, which are of course on the primary side, we undo the large nut that we loosened prior to removing the engine from the frame. Now the large retaining washer can be removed. This slides off. We're now in a position to remove the primary drive pulley or sprocket. This also simply slides off. Take hold of the rotor and pull it away. Because of the magnets inside, it won't be easy. You may have to use a puller. We remove the 4 screws and retainer clips with a flat blade screwdriver. Rest the stator on the shaft, and using our Phillips screwdriver, we can remove the nylon retaining bracket. With a blunt instrument, we then push the plug back into the motor. Once this is free, you can remove the stator. To split the cases, we must undo all the nuts and bolts holding the cases together and remove them, all except the studs in this configuration, the one at the top, the one at the bottom left, and the one on the bottom right of the screen. We'll place them in the corresponding holes in the card. Remember, these studs hold the cases in the correct alignment. Mix them and we could misalign the crank cases. Taking a soft hammer, we'll tap the crank. Pulling the case at the same time, the cases will split, exposing the crank. What we're looking at now is a 5-piece crank with the conrods intact. The flywheels will need to be pressed out from the remaining case, then the crank is serviceable. At this stage we recommend that for any further servicing, the complete crank and case should be taken as is to a reputable engineering workshop experienced in this type of work. To remove the rocker box from the head, we use a 1/2-inch ring spanner to remove all the 9 nuts as shown. With a soft hammer, we'll tap the rocker box using an upward motion. This breaks the seal. We can now raise the rocker box assembly. Inside the rocker box assembly, we have the rocker arms. These operate our valves. We now remove our rocker box gasket. It's usually baked on and broken. Using a valve spring compressor, we can now compress the valve springs. It can be done without the spring compressor, but because it's a cheap item and very accessible, we advise you to use it. We place the splayed end over the top of the valve stem. The other end of the valve spring compressor is placed over the head of the valve, like so. Continue to wind it in, as we need to apply considerable tension to the valve springs. This process of winding is not easy and requires a fair degree of pressure. However, keep winding until the spring tension is taken off the valve collets. If we're lucky, they will fall out, as this one has done. We need now to pry out the other collet. Be careful not to lose these collets. You're advised to keep the pairs of collets together, as the collets are a matched pair and must go back on together later. Once the tension on the springs is released, we can now remove the valve spring retainer washer. We then remove the dual springs. These consist of one spring inside the other. The dual springs return the valve to the closed position after the valve has been pushed open. If any of the springs are broken, replace both the inner and outer springs for the corresponding valve. To remove the valve, we push the valve stem through the valve guide. We may in fact have to apply considerable pressure to force the valve past the guide seal. This seal is destroyed in the process and must be replaced. The other valve assemblies are removed in exactly the same manner. We need to remove the base washers and the valve guide seals. These seals that we're working with here are old and worn and come out easily. Generally, however, more effort is required to remove them from the valve guides. The valve guides hold the valves in place. These are also serviceable but require considerable heat to remove. We recommend that all work done on the valve guides and seats be done at a reputable workshop. The exhaust and inlet valves are easily identifiable, but to ensure that the valves from the front and rear cylinders do not get mixed up, we keep them separated and identified by placing them in cards like this. Placing a 5/16 Allen key into the cap screw as demonstrated, and using a 5/8 ring spanner, we can now disassemble the rocker assembly. Holding the Allen key firm, we can now undo the nuts on the other end. We repeat the procedure for the other set. These nuts on the end of the shaft will be firm and most likely require some effort to loosen. We're now in a position to remove the washers off the ends of each of the rocker shafts. With a soft hammer, tap the shaft back into the rocker while rotating the Allen key. Once the shafts are flush with the rocker case, we can then drive them out using a punch and a soft hammer. Of course, this procedure applies to both the front and rear rocker assemblies. It is now necessary to remove the rocker shafts. Once the rocker shafts have been removed, we can then proceed to remove the spacer. The spacer that sits at the end of the rocker arm can be removed by holding the rocker arm back with our finger. We then give it a bit of a shake and the spacer will fall free. The spacer, of course, takes up the end play on the rocker arm. Speaking of the rocker arm, we can now remove it. It comes out quite easily. The left-hand extension of the rocker arm pushes the valve down and is prone to wear. If worn, the tip of the extension will be uneven and will require machining. We must now disassemble the rocker shaft itself. We'll need to remove the end cap so that we can replace the O-rings underneath. We'll be using our 5/16 Allen key. If you need to clamp the shaft, under no circumstances should the grip be applied to the two bearing surfaces. Apply it here, between the bearing surfaces. Because we've already pre-loosened the end cap on the shaft, it comes off easily. Once separated, we can remove and discard the O-ring that sits underneath. To make the job of reassembling easier, it's important to remain organised, so keep all the components in their respective sets. This now completes the disassembly of our Shovelhead motor. The motor reassembly commences with the assembly of the rocker and the head. After all rocker assembly parts and surfaces have been oiled, we insert the spacer like so. It sits snugly up against the face of the journal. With the spacer in position, we can now insert the rocker arm. It slips in one way only. Now for the rocker shaft. We steer the shaft through the rocker. We'll need to manipulate the rocker to enable a clear passage through for the shaft. As we can see, once the shaft has completed the journey, it will rest snugly in the rocker case. We now replace the washers and the nut on the external threaded end of the shaft. We then tighten the nuts with a ring spanner, or for greater precision, a torque wrench to 16 foot-pounds. At the other end we insert the new O-ring seals. We must make the O-ring seals sit flush. We're now in a position to screw on the cap screw. That will ultimately be tightened to 13 foot-pounds. Here we're using a 5/16 Allen key to do the tightening. Now for the valves, but first we'll insert a valve stem seal. We'll carefully tap it into place. Yours may in fact be different due to manufacturing changes. Before inserting the valve, we oil the valve stem and insert with a screwing motion, pushing the valve stem through the seal. Ensure both the inlet and exhaust valves are in their correct seats. The valves are not retrievable without ruining the valve seals. The large base washers are the next components to be put into place. We now slip on the double valve springs, followed by the retainer washer. Once again, using our valve spring compressor, we compress the springs. We apply the compressor in the same manner as we applied the compressor in disassembly. Using the compressor is a fiddly business. Once in position, you can compress the valve springs, making room for the collets. While inserting the collets, we must ensure that the thin edges face down. These tiny collets act as wedges that contain the spring and the valve components at high pressure. When the collets are correctly in position, we can release the pressure on the spring by removing the spring compressor. All valve assemblies are carried out in this manner. After the assembly, it's a good idea to test each of the valves. Tapping them with a soft hammer should provide enough stress on the valves to bring them apart, if in fact they were going to give. Before installing the rocker, we must first apply a good quality sealant to the gasket surfaces. The gasket then slips on. While laying the rocker on its back, we must push both the rocker arms down as demonstrated. We then proceed to place the head on the rocker box. While holding the gasket in place, we insert the studs into their corresponding holes. Before replacing the nuts on the studs, we must make sure that we have placed the heads on the correct rockers. Only the rear head has two oil couplings on the rocker, so it can be very easily identified. Before putting the crankcase back together, we must oil all bearings and their surfaces. We must also clean the mating surfaces and use a good quality sealant as there is no gasket. Carefully slip the right side of the crankcase over the pinion shaft. Taking the 3 studs we placed in our reference card earlier, we insert them into their corresponding holes. This aligns the case, and we can then proceed to replace all studs. Observing from the primary side, these 2 bolts are tightened to 25 foot-pounds, while all other crankcase studs are tightened to 16 foot-pounds. We insert the oil pump drive shaft with its 3 keyways, with 1 keyway to the inside, while 2 remain outside the case. We then place the drive gear so that it meshes with the worm gear on the pinion shaft. Now this is a fiddly exercise, but pay particular attention to the angle of the keyways on our pump shaft. The drive gear keyway should correspond with this angle. Once the pump shaft is pushed through the gear to expose the end keyway, we can then insert the woodruff key. This is a particularly delicate procedure, but once the key is in place, we push the shaft back into the gear. There are 2 pairs of gears still to be installed, 1 small pair and 1 large pair. Here we see the different sizes. We now replace the woodruff key on the shaft. Select a large gear with a keyway and slide the gear into place. The gear should not rotate on the shaft. Now replace the matching large idler gear onto its shaft in the pump body. We're now in a position to slip the body gasket into place. We then slide the pump body over the shaft. When the gears mesh, it will sit up against the crankcase wall. With the 2 top mounting bolts in place, we slip the idler gear on the shaft without the keyway, while the drive gear is placed on the other shaft that has a keyway. Of course, we've already inserted the woodruff key in this keyway. To secure the drive gear, we replace the circlip. The replacement circlip, of course, should be brand new. To replace the oil pump outer cover, we first insert 2 bolts that will loosely hold the gasket in place. After all bolts are tightened to 10 foot-pounds, we can replace the small circlip on the other end of the pump shaft. This circlip holds the drive gear and woodruff key in place. We now replace the tappet oil screen, then the spring, and now the oil screen cap with the new O-ring. To reassemble the cone, we first turn the motor until the timing mark on the pinion gear is at the 11 o'clock position. Replace the shim on the end of the cam, along with the winged thrush washer. The wings face downwards with the cutaway at the top. When putting the cam into place, the timing marks must line up. If they don't, then we'll need to try again. Keep juggling until they do. It is essential that these marks do line up, otherwise the valves could collide with the pistons, causing severe damage. Once the cam is aligned, we can now insert the breather gear. Once again, we line up the timing marks. All 3 marks should align exactly as we see them here. If the breather isn't lined up, severe crankcase pressure can result. This is the spacer for the breather. As we can see, it has a tapered inside bore as well as a flat side. The tapered side must face the breather. Like the breather, the spacer can be made of nylon or steel. 2 dowels on the face of the case align the cone gasket. Once again, we should be using a reliable sealant on the mating surfaces of the case and cone to ensure an oil-tight seal. We replace the cone bolts and tighten them to 10 foot-pounds. As we look into the centre of the cone, we can see a slot. This slot is for this pin on the rear of the advanced retard unit. On the other side of this unit there is a points cam. There is only one correct way to fit this cam. This is when the shaft clears the points cam by about 1/16 of an inch. When the unit is assembled in the engine, this bolt holds it in place. The clearance we observed between the bolt head and the points cam allows the bob weights to turn the cam back and forth. This advances and retards our timing. When the points cam rotates, it lifts the points to create our ignition spark. The advanced retard unit is aligned when the pin sits in the cam slot. We'll need to rotate the unit until the pin slips in. Once the unit is correctly in place, we should grease the points cam shaft. We can now put the points cam on. Remember to do it as we demonstrated earlier, otherwise we'll have a problem with the clearance. Using a reliable thread locking compound, we can now replace the points cam retaining bolt. Because this bolt has such a large head in comparison to its shaft, it's very easy to strip the thread, so careful. Now for the points and condenser backing plate. This backing plate is held in position by the locking screws. We don't tighten these, however, until the points gap and timing adjustments are made. That's after the engine is finally reassembled. We will, of course, show you how to set and adjust these points later. Once we've oiled the tappets and the blocks, we insert the cam followers, making sure that the flat cutaways with holes are facing towards the centre and each other. Turn the block over, holding 2 fingers on the bottom of the rollers to stop them falling out. We then insert our 2 hydraulic units. To prevent the cam followers falling out, we squeeze the hydraulic units together. Before the tappet block goes into the crankcase, we'll seat the gasket, making sure the oil holes in the crankcase and in the gasket are lined up. Damage may in fact result if the oil hole is blocked by the gasket. The words front or rear are usually cast into the tappet blocks. All we have to do is place our tappet block into its corresponding recess. However, it is critical at this stage that we do not release the pressure on the hydraulic units, as the cam followers could drop into the crankcase. At this point we need to pour about 500 ml of oil in through the tappet block hole. We'll tighten our bolts diagonally and evenly to 12 foot-pounds torque. Of course, we repeat the procedure for the other tappet block. We tell the difference between the front and rear barrels by facing the bottom 2 cutaways towards each other. These 2 oil holes on top, highlighted with white, should face the primary side. There are other identifiable casting features on the barrels, but we find this way easier to remember. Before placing the rings on the pistons, it's a good idea to test them inside the barrel for size. Each set of rings must in fact be measured in the bore they're going to be used in. We then insert a piston to square the ring. Naturally, this should be the piston that matches the bore. We then measure the gap with a feeler gauge. If an old bore is to be refitted with rings, we would normally measure the top, middle and bottom of the bore. The tolerance for the gap of the compression rings is 10 to 20 thou, while the oil scraper rings is 10 to 45 thou. The clearance between our piston and bore is 2 to 5 thou. The ring gaps can be enlarged by using a fine cut file. To replace the piston, we must work out the correct operating position of the piston. In most cases, the pistons have a lump cast into the gudgeon pin journal underneath. This lump faces the cone or gear case of the motor. We need to have already warmed the piston in an oven and frozen the gudgeon pin. Now that we've worked out which is the front and rear of the piston, we'll oil the gudgeons and quickly insert the gudgeon pin, without pushing it through just yet. We place the piston over the oiled conrod, line up the gudgeon pin, then push it through, making the recesses for the circlips clear. We can now insert the circlips. We stress that we shouldn't use the circlips more than once. Damage to the bore and piston will result from lost tension. It's just not worth it. use a new circlip and throw the old ones away to eliminate the chances of mixing them up. It's not an easy exercise inserting the two circlips, so we've got to be careful not to damage the piston skirts. Let's now have a closer look at the rings. There's usually 5. There are 2 oil scrapers. These are the thin rings to the right of the screen, with the segmented ring or spreader between them. The 2 other rings are compression rings. The first ring to go on is the segmented ring. The thin oil scrapers are placed either side of the segmented ring in the 3rd groove. The ring gaps should be staggered at least 2 inches apart to regulate oil flow. When putting on the compression rings, which of course should be new rings like all rings, the one with the dot goes on first. With the dot facing up, work it into the 1st groove. Then, spreading again, we work it into the 2nd groove. This is where it rests. Be careful when spreading the rings, they're fragile and could warp or break. Once again, stagger the ring gaps by at least 2 inches. Now for the last ring. We place it on the top groove, and again we stagger the gap. At this stage we always fill the ring landing with oil and spread oil over the skirts of the piston. Oil left on the hands can be smeared into the barrels, which we are now ready to install. We need 2 pieces of wood to stabilise the piston and a rag to stop dirt falling into the crank. Bring the piston down onto the blocks of wood. To slip the barrel on, we need to compress our rings. If we don't have a ring compressor handy, we could make one from a large hose clamp. Make sure it's not too tight, preventing it from sliding down when the barrel slips on. We have left a bit of the piston showing at the top. This starts the barrel. Using a reliable sealing compound, we can now put the new barrel base gasket onto the barrel and place the barrel over the piston. Applying pressure downward, the barrel will go onto the piston. Make sure the rings are going into the bore and not catching on the bottom of the barrel. It's not an easy exercise and it will require a bit of patience. Press down until all the rings are in. Remove the ring compressor, being careful not to drop the barrel. Aligning the barrel mounting holes to the studs, we can push the barrel down a bit further, almost to the 2 wooden blocks. Carefully remove the first block of wood. Then, supporting and steadying the barrel, we can remove the 2nd block. Remove the rag, making sure that no dirt particles collected drop into our newly assembled crank. It's now safe to push the cylinder all the way down, steering it over the 4 barrel base studs. We repeat this procedure for the front cylinder assembly. Before we bolt down the barrels, however, we must insert a head bolt in each of the barrels as shown here. These particular head bolts must be placed in now, as we cannot insert them once the barrel base nuts are in place. We stress this must be done now before we tension the barrels. The barrel base spacers have been stamped to show the way they should be placed over the barrel base studs. With the spacers in place, we now put the nuts onto each barrel base stud and tighten diagonally and evenly to 33 to 41 foot-pounds torque. Once tightened, smear some more oil in the bore. This then completes the reassembly of our front and rear cylinders. When replacing the head gasket, we make sure all the holes in the gasket match all the holes in the barrel. To tell which are the front and rear heads, we look for the pushrod holes. These face the cone side. The rocker's top oil couplings face the centre. Placing the front head on the corresponding barrel, we insert a head bolt. Feel the bolt go through the gasket into the head. Then start the bolt. We then screw the rest of the head bolts into place without screwing them up tightly. We do the same for the rear head. Once the heads are in place, we can now replace our oil lines. When replacing the main oil line, remember to position the bend correctly, like we have here. With the top oil line, we twist the rear head and insert the oil line, ensuring it arches between the heads. Note, both our oil lines are only hand tightened at this stage. Before tightening the head bolts and oil lines, we align the head assemblies using the intake manifold as a guide. From the top, we see how it's done. We prefer to use a 60-degree set square, aligning the sides of the inlet ports flush with the square. Carefully nipping up a couple of the head bolts in each head, we recheck the intake ports alignment. Tighten the oil lines. Then we tighten up the rest of the head bolts evenly and diagonally, 1/4 turn at a time to 55 to 70 foot-pounds. Turning the primary pulley will raise the front piston to reach the compression stroke. The front inside cam follower will rise and finally fall. We now remove the hydraulic units from the cam followers in order to bleed them. We bleed them one at a time to avoid mixing the hydraulic components. By inserting a match and pushing up gently, we raise the valve. Pushing with our thumb on the hydraulic unit, we force any remaining oil out. The unit is now bled. These hydraulic units comprise two basic parts. When oil passes up through the valve, the oil pressure lifts this piston, seen on the right, into position and holds it in place, thus keeping constant tension on the push rod. We bleed the unit once again to release any airlock. To test the hydraulic unit, we place our finger over the inlet and try to remove the piston. If there is a strong vacuum, the unit is okay. Note, all four must be done this same way. We stress don't get the components of the hydraulic units mixed up. Each set is machine matched. Before replacing the push rods in their covers, we discard all the old seals. The spring-loaded cap you see here houses a washer, a spring, and of course the new O-ring. For ease of installation, the O-ring on this end is best inserted into the tappet block itself. All of these O-rings should fit quite snugly. We can now insert the push rod. All hydraulic push rods, by the way, are the same length. We now replace the top O-ring and place the whole unit into the rocker first. We then screw the push rod adjuster down into the hydraulic unit. In order to keep the cover up, we insert our trusty peg. We then screw the adjuster all the way down until the hydraulic unit's spring is fully compressed. We go no further. Using two 7/16 spanners, we back off the adjuster nut 1½ turns. Naturally, we use the split in the lock nut as our guide. The other spanner holds still the actual push rod. Securing the adjuster nut with the same spanner, we wind the lock nut all the way to the top. Once loosened with our spanners, this process can be carried out easily by hand. But now comes the fiddly part. When the locking nut is at the top, we need to keep the spanner on the adjuster nut. We then take another 7/16 spanner and place it on the push rod. Holding both these still, we then use a third 7/16 spanner to firmly lock the split nut. This nut is torqued down to 12 foot-pounds. The other three push rods are inserted and adjusted just as you have seen. Removing the peg from the push rod, we place the base of the push rod cover into the tappet block. Making sure the top O-ring is still in place, we use a screwdriver to extend the top half of the push rod cover up and into the rocker box, ensuring it is seated correctly. Now we insert the top of the retaining clip into the rocker box. Using a flat blade screwdriver and the base of the retaining clip as a pivot point, we push the cap down and slide the retainer clip into position. We use this same procedure for the remaining three push rod assemblies. With one rubber and clamp loosely in position and the other rubber on the inlet manifold, we wiggle the carby into position and check there are no folds in the rubbers. Holding the carby level, make sure the clamps are done up firmly. Of course, before we get to this stage, we should ensure that both the rubbers and clamps are in good condition to prevent any air leaks. If air leaks are present, problems will arise with the fuel-air mixture. Resting the stator on the crankshaft, we must face the plug and its wires towards the cases. Having lightly smeared oil on the plug, it can be pressed into position relatively easily. We use a screwdriver or blunt instrument and push the plug all the way home. Next, we replace the nylon retaining clip, being careful not to over-tighten the small screws, as the threads in this case are very easily stripped. We have used the reliable thread locking compound to stop these screws vibrating loose during operation. Lifting the stator into position, we line up the 4 mounting holes. Taking the retaining bracket and 2 retaining bolts, we insert them. You'll notice there are 2 sets of retaining clips and bolts. We use our reliable thread locking compound on these bolts to prevent them vibrating loose while the bike is in use, thus avoiding considerable damage to the rotor and stator. The rotor simply lines up on the splines and slips back. As you can see, this requires very little effort. The primary drive pulley slips on the crankshaft in the same manner. The retaining washer is the next part to go on. This is followed by the retaining nut. We only finger tighten the retainer nut at this stage. We will ultimately tension this retaining nut when the primary drive system has been assembled in the frame. Removing the timing hole inspection plug, we're able to see the left-hand flywheel. By rotating the flywheels, we're able to observe the timing marks which are engraved in the surface of the flywheel. With a thumb over the front spark plug hole, we can feel air escaping as the motor is rotated to find the front piston compression stroke. The first mark observed through the inspection hole usually represents 35 degrees before top dead center. This mark is used for dynamic timing. We keep rotating the motor the same way until the next mark appears. This represents front piston top dead center and is the static timing mark. To get to 3 degrees before top dead center, we rotate this mark back to the right-hand side of the inspection hole. This is where we leave the flywheel for setting our points assembly. Loosening the retaining bolts, we rotate the base plate until the heel of the points sits on the top of the points cam lobe. For demonstration purposes, we remove the points cam bolt. This provides us with a much better view. Notice that the heel of the points sits on the smaller cam lobe. Of course, when setting the points, the points cam bolt should be firmly in place. We can now lock the backing plate in position by tightening the 2 locking screws either side of the plate. Using our flat blade screwdriver, we loosen the points adjusting screw. Once loosened, we then push the points plate down. Holding them in the open position, we nip up the adjusting screw tight enough so that our points will remain open. At this stage, we are still able to adjust the points plate, though some effort is required. Now, with our feeler gauges set to 16 thou, we can insert them in the gap. The right gap is found when the feeler gauge moves in and out of the points gap with only very slight resistance. Of course, it may require several attempts before the gap is adjusted correctly. When we do eventually succeed, lock the adjusting screw down, then recheck the gap. This process, of course, may at times need to be repeated. Naturally, we'll need to rotate the backing plate to the left, so the points heel is just in front of the lobe. We then tighten the points cam bolt. For electronic ignitions, we first insert the rotor plate. This rotor engages the recess on the cam. Correctly locate it. This unit has gaps cut into it to send a pulse to the sensor plate. Insert the bolt and tighten firmly, but don't over-tighten, it might warp the rotor. We use 8 foot-pounds torque. Replace the sensor plate so that the two retaining bolts will be in the center of the slots at the left and right of the screen. Replace the retaining screws. In doing this, a slight adjustment may be necessary. Tighten the retaining screws. This process will be sufficient to get the bike up and running. A proper dynamic adjustment is best done on these units while the engine is running and with a strobe light, as these units are extremely accurate. We can now insert the two new spark plugs, checking that the electrode gap is set between 38 to 42 thou. This now ends the complete disassembly and assembly of our Shovelhead motor. The engine stand used in this video is an easy jig and is a patented stand that is used for shovel and evolution motors. The stand is exclusively available through video manuals. Regarding inquiries relating to the jig and any other videos in the video manuals library, contact Video Manual, 28 Duncan Street, Fortitude Valley, Queensland, Australia.